Hi guys, and welcome to Learn Extra Live. We can't believe that it's Tuesday already, and as you can see, I've got Tracy standing next to me, and grade 10, she is with you for the entire hour. Trace, how are you?
Fine, and you?
Good. Okay,
Good,
so
I'm
what?
so excited.
Yeah.
Well, we're doing revision. So today, guys, we're going to look at the chemistry. We're going to do questions. We're going to do some stuff of what you've done this term. And to start the show, when we go to me, just now I'll speak English for you guys in a second. I actually have a challenge question today.
How exciting!
So we'll see.
That's exciting.
Yeah.
You know what? I think I've decided we're going to make this challenge question. The person who comes up with the first correct answer is going to win a calculator. What do you
Yes,
think?
with an explanation though. So you can't
With
just,
an explanation.
I need to know why. So they can't just give me, because it's multiple choice. So otherwise
Okay,
they're just going to take a guess.
exactly.
And I need to have the right answer
And
with the
why?
right reason.
And why? Okay,
Yes.
awesome.
There we
Take
go.
a little spot and
Thank
I'll
you.
do my thing. Okay, guys, so this is everything you need to know. We've got a challenge question coming up, and what we're going to be doing is we're going to be giving our Casio calculator to that winner, whoever has the first correct answer, but also make sure that you put why, reasons why. We want to see why, because we can't just give it to anyone. It has to be for the top answer. Guys, join us on facebook.com/learnextra, and also chat to us on Twitter @learnextra. This little Facebook community and this two-way chat, it's for you guys. It's so you guys can chat to each other, learn more, and learn extra. So please, please use it. So now without further ado, I'm going to pass it on to Tracy. Chat to me on the page. And Liberty, you guys rock. Thank you so much for making this possible. We think you guys are awesome. So now, Tracy, take it away.
Thanks, Indy. Okay, well, guys, like I said, we're doing chemistry revision. So I have a question for you guys. And it's a multiple choice question, but like we've said to you, you've got to give us the reason why you think the answer is what it is. So the question says, 1 gram of hydrogen gas at STP, that's standard temperature and pressure, okay, occupies a volume of either A, 5.6 decimeters cubed, or B, 11.2 decimeters cubed, C, 22.4 decimeters cubed, or D, 44.8 decimeters cubed. Okay, I'm going to read it again so those of you who are busy writing it down can make sure you get it. 1 gram of hydrogen gas at STP occupies a volume of A, 5.6 decimeters cubed, B, 11.2 decimeters cubed, C, 22.4 decimeters cubed, or D, 44.8 decimeters cubed. And I have chosen this for a reason, grade 10s, okay? Don't just put the first thing down that pops into your head. Very, very important. Okay, so let's get started. Like I said, we're going to do a whole bunch of questions, but what those questions are going to focus on are the things that you've actually done this term. So we've looked at, particularly at Learn Extra, we looked at reactions in aqueous solutions, which is the whole dissolution process. We looked at different types of reactions, redox, ion exchange, those sort of things. And then we spent some time doing moles and mole calculations and that sort of stuff, which we know can be a little hairy at times, but that's okay. So, jumping right in, let's look at reactions in aqueous solutions. First one is give balanced chemical equations, okay, very important. So I'm also going to show you some exam technique as we go along here, grade 10s, because the sooner you get your exam technique done, the better it is for you. So these are the habits I would love you to get into because it's really going to help you. Give balanced chemical equations. So first of all, we know it's got to be balanced. That's really important. To show how the following substances dissolve in water include all phases, okay? So this is got several parts to it. I need to give balanced chemical equations. I need to make sure that I know what it's like when it dissolves in water, and I need to include all the phases. So if we look at the first one, sodium chloride, we go, okay, formula for sodium chloride, you really should know this one by now. You've done this over and over and over. NaCl. Now, I'm sure some of you are going, okay, you're not NaCl, but remember how a ionically bonded substance and how a covalently bonded substance dissolves in water is different. So the way we write it is different. So now I need to identify whether that's ionic or covalent. So we say to ourselves, okay, it's sodium plus chlorine, so it's a metal plus a non-metal. It must be ionic. Ionic means it dissociates, okay? So it's going to split into its ions, but the water is really just there to help it split. So when we look at this, we go, okay, NaCl, but it said include all the phases, so that's solid. It's ionic, which means that we're not going to add water. We're going to make water, it's not a catalyst, it's there because it has to be, but the water needs to be on top of the line, okay, because it's not going to take part in the reaction. Then we end up, it dissociates, so that means it's going to turn into its ions, so knowing their valencies is really important. So we get Na plus, but it's got to be phases included, which means it's now dissolved in water, so it's aqueous plus Cl minus, which is also aqueous. Remember, sodium is in group 1. It's in the first group in the periodic table. It is a metal. It is going to give away its electron, which means it becomes a positively charged ion. Chlorine is in the halogens, which is in the second last group, group 7 or group 17, I think it is. Doesn't actually matter. Becomes negative because in that last group it really wants to take electrons. There we go, nice and done. This would be worth 3 marks in a test. Okay, 3 marks, and it's about being able to do the HCl, the NaCl, sorry, the H2O in the right place, and the NaCl plus Cl minus. Next one. All right, hydrochloric acid. Hydrochloric acid means we're looking at HCl, okay? Hydrochloric acid, HCl, 2 nonmetals, must be a covalently bonded substance, okay? Covalently bonded substance, which means the dissolving process is slightly different. It also means that we're not dissociating, we're ionizing, okay? So instead of, this isn't ions, this is a sharing of electrons, so I need to split it. I need to get it into a place where now it can split into ions, okay? So, HCl. We're going to dissolve it. It's a hydrochloric acid, guys. You cannot get a solid acid, okay? Acids are liquids. Generally, it actually has to be aqueous, but it's okay. So here, we would put liquid or aqueous. Aqueous is actually, let's put aqueous, is actually more correct. So we'll put aqueous, but look here. The water, which is a pure liquid, gets added in. It's not on top of the line anymore. It gets added in. Now what's going to happen here is the hydrogen chloride, the HCl, the H, okay, is going to come off and it's going to bond to the H2O. So we end up with H3O plus, which is dissolved in water, and Cl minus, which is aqueous, okay? Let's just get rid of this random little thing. I don't know what that was. Okay. Very important that you get the difference. Ionic, we put it above the line because it dissociates. We break it up into its ions. Covalent, we have to put the water into the equation, and one of the ions will move off into the water. Okay. Generally, we'll probably give you nice, easy covalent ones because it's not the nicest one to do. Very important that you get that. Okay. Ready for another one? I think so. All right, next question. Now it says to you, zinc 2 sulfate reacts with barium iodide to form zinc 2 iodide and barium sulfate. I have been very mean with this question. I didn't give you any formulas, okay? First question, write a balanced equation. There we go. Write a balanced equation. Can't even begin to write a balanced equation if I cannot write formulae. So that's where we've got to start. Okay, we've got to start with writing the formulae. They said to us, zinc 2 sulfate. Okay, now I'm going to end up rubbing some of this off. So zinc 2 sulfate, zinc 2, the 2 tells me that the sulfate has a charge of 2, sec 2, a valency of 2. Sulfate, you must know, is 2 minus. So we've got zinc 2 plus, sulfate, which is SO4 2 minus, so it's zinc 2 plus, SO4 2 minus. It's a 1-to-1 ratio, so this is nice and easy. When I write zinc sulfate, should have used a bigger eraser. Okay, it becomes ZnSO4. Okay, let's put phases in because we're going somewhere with this. It reacts with barium iodide. It's not solid, sorry. It's going to be an aqueous solution because they're solutions, which I should have put into the question, but I didn't. Reacts with barium iodide. Barium, okay, is a multivalent. It's in group, I can't remember right now, but its valency is 2. I'll get there eventually. It's multivalent. Iodine is in group 7, valency of 1. So I need to have 2 iodines to every barium. Okay? Now, they're so nice here because they said to you it forms zinc 2 iodide and barium sulfate. Bonus! I don't even have to think about this. This is an ion exchange reaction, okay? So we are getting ions changing place because the zinc and the barium are changing place. But there's a little twist to this because whenever you get a reaction between 2 solutions like this and they tell you what you get at the end, you have got to check if something is insoluble. So you've got to go back to your rules of solubility, okay? We get zinc iodide, which becomes zinc iodide like this, and we think about the rules of solubility, and we go, that's fine, zinc iodide will dissolve. Okay? We get barium sulfate, which will be BaSO4, but this is the trick. Barium sulfate is insoluble in water, okay? In fact, most salts of barium are insoluble. Very important. We love giving you barium sulfate. It's one of the ones you're going to see often. You need to learn it for grade 10. Another one that you're going to see often and comes up in grade 12 again is silver chloride and silver nitrate. Becomes a bit of a trick one. So we go, okay, cool. Now, if I didn't realize there was a trick to this and go, they wanted the whole solution thing, look at the next question. Write an ionic equation for this reaction. Now you've got to say to yourself, well, if it's just a plain ion exchange and everything is soluble at the end, why would I ask you for this? That's a bit silly because now look at the next question. Write a net ionic reaction for this equation for this reaction. Now you've got to be saying to yourself, okay, now I know something's got to be soluble because that's the only reason why we'd ask you for net reaction. So if you haven't identified here something as being soluble, you need to make sure you go back and look at it. Okay, being insoluble. Ionic equation. That means we write everything out as ions, okay, except for what's insoluble. So in other words, I'm going to have to write a little smaller now to try and fit it in. So zinc 2 plus, which is an aqueous, plus SO4 2 minus, which is also now aqueous, plus Ba2 plus. It gets very boring after a while, but that's okay. Trick, careful. I've seen this lots. Iodine is -1. There just happens to be 2 of them in the barium iodide solution. Okay, you can't write it as I2 to the -1 because it's not. Then we get zinc 2 plus, 2 more iodines again. Oh, and look here. The barium sulfate stays as it is. You can't split the barium sulfate because it doesn't dissolve. It doesn't form ions. So you cannot split it. You've got to leave it as barium sulfate. Now, the next one says, write a net ionic reaction. That means I need to look at my reaction and go, okay, what stayed the same? Okay, I'm going to just circle it in blue. You don't do this on your paper. It's just for you to see. So zinc is zinc 2 plus and zinc 2 plus. Zinc 2 plus. Sulfate went from no longer dissolved. Something's happening there. Barium went from being dissolved to no longer being dissolved, and iodine stayed as I minus. What that means is that the zinc and the iodine are there, but they're not really important. Just don't tell them that, okay? They have to be there because without the zinc and the iodine, I can't get the barium and the sulfate ion in the first place, okay? So I sort of need them to get the whole thing going. Once it's going, though, they're just pretty useless. So the net reaction, and it's just a convention that we always write the positive one first. It doesn't matter. SO4 2 minus, which then becomes barium sulfate as a solid. Now, I'm pretty sure some of you are going, but how did we know to put in the phases? Grade 10s, please just do yourself a favor. You are never going to get marked down for putting phases in, particularly if we're looking at a reaction with a solid. Something with a precipitate, you absolutely have to put the phases in. You will never get marked for it. So if you're not sure, put the phases in. Okay? Wow. Indy, I think they
Have
need
you
a break.
spoken enough?
I have, yes. Well,
Okay,
never, but, you
okay,
know.
guys. We'll let Tracy have a break. It's just going to be a little fast, quick one. I just wanted to give a quick wave out to Dr. Fulani. He's always on the page. He says, "Afternoon, guys." He is on the page, and that's exactly what you guys need to do. Please post if you have any questions for Tracy. Post them on our page. Tweet us at Learn Extra. Let's help you learn more, learn extra. See you now after the break. Hi guys, and welcome back to Learn Extra Live with this physical science grade 10, and you are with Tracy. And if you have been watching and you have any questions, please post them onto our Facebook page. That's facebook.com/Learn Extra. Also chat to us on Twitter at Learn Extra. Guys, sometimes it's so nice learning, you know, like if you post a question on the page, you never know, another mindsetter may write back, or maybe you'll be the mindsetter that knows the answer and you'll be posting back. So there we start to create this little community of people, mindsetters that help each other out. And I see, Tracy, we've got about 20 comments on our challenge question.
Oh, really?
So it's definitely on its way.
Okay.
And I see quite a few promising answers. Guys, don't forget. Yeah.
I'm not sure Indy would know.
That's only yeah, don't trust me. Maybe trust Tracy.
Sorry, Indy.
Exactly. Okay. So now, guys, I just got to tell them because I do have them saying to me, you know, answer C, A, B, D.
Mm-hmm.
Please, guys, put the reasoning why.
Yeah.
If you put C, why is it C? Let us know why.
Absolutely. I mean, if you get the right answer and you haven't given us the right reason, we're not going to give it to you, because what I'm trying to get from you grade 10s with this is, I know come multiple choice in your tests and exams, you play multiple guess, or it's called a monkey puzzle or whatever. And, you know, I will honestly say to you that if you really don't know the answer, never leave multiple choice out, take a guess. But I want you to learn the point that multiple choice is an art, it's a skill, okay? So with multiple choice, it's really important that you learn to work your questions out, okay? And you don't just go, oh, I know the answer, and go, yes, you must go with your first instinct, but it's important that you know why you're going with that. Okay, grade 10, so I really want to see your reasoning. And also that gives me a good indication of where you're going. It makes it easier to help you, basically. Okay, so now we get to the section which I know my grade 10s absolutely hate, but it's okay. Here we go. A sample of an oxide of aluminium is analyzed, and it is found that the sample contains 52.94% aluminium and 47.06% oxygen. Determine the empirical formula, okay? Now, grade 10s, this is actually such a nice section. This is the opposite of finding percentage composition, okay? You should have done that as well. When we give you a compound and we say to you, say, for example, we give you hydrogen and we say, determine the percentage composition of the hydrogen and the oxygen, and off you go. This is the reverse. And in fact, grade 10s, this is a very simplified version of how chemists, how researchers find the formula of unknown compounds. When they, for example, when they dig up ore and they want to know what's in the ore, they crush it, they do all sorts of things, they do a whole bunch of tests, and eventually they can see the percentage composition by weight. Okay? This is a weight percentage composition, not a percentage composition by number of atoms. Because remember, aluminium and oxygen have different masses. They're different atoms altogether. So, with this, there's a couple of really, really easy steps, and we're going to go through them. Number one, you always assume you have a 100-gram sample, so we write that in. Maybe I should write it so you can read it. Assume a 100-gram sample. Now, the reason why we want a 100-gram sample is because if I take 52.94% of 100, it's 52.994 grams. If I take 47.06% of 100, it's 47.06 grams, okay? So that means we have, and let's just put it here, we have 52.94 grams of aluminium, and we have 47.06 grams of oxygen. All right, grade 10s. Please listen to me. As a teacher, my biggest frustration when I'm marking is I don't know what you're doing. I don't know where you're going. All I see is random numbers. There's no equations. There's no formulas. Or there's equations, but I don't know if you're working out the aluminium or you're working out the oxygen. So your layout is really, really, really important. Okay, I'm begging. Now, if we want the empirical formula, the formula of the compound tells me the ratio in which the atoms bond. So that means I need to work out what's the ratio of the number of moles of each of these. Okay? So we start with the aluminium, and we go number of moles of aluminium means I'm going to go mass given divided by molar mass. You don't have to put the aluminium in brackets, but what am I doing? I'm making sure that whoever looks at this knows exactly what I'm working out. So we go, all right, and aluminium has a molar mass, so we go and look on the periodic table, of 27, okay? So that means we're going to go 52.94 divided by 27, and we get 1.97. Don't forget, I need to know number of moles. So I must put the unit moles. I need to know what you're working out. Okay? Let's do the same. I'm going to change color with the oxygen. How would we know? Well, we go number of moles of oxygen, mass over molar mass. Now, what is the molar mass of oxygen? And I know if I could hear through the TV, someone is screaming 32. And I'm going to scream back, no. 32 is the molar mass of O2, oxygen gas. Be very careful. I'm not working with O2. Once oxygen is bonded, once it's in a compound, it's no longer diatomic. Okay, it is only diatomic in its elemental form, which means here I must use 16. Okay, and now we get 2.94 moles. Now things go a little pear-shaped. Okay, I've recently had an argument with my grade 10s at my school because they were very unimpressed with me. But it's okay, they'll get over it. All right, so now listen. We are now going to take, let's not get rid of all the answers, okay? The ratio of aluminium to oxygen. Aluminium, 1.97. Oxygen, 2.94. What we would do from here, okay, is usually we would divide by the smallest number. So I want you to see something. Okay, let's just put it up the way. Dividing by the smallest number means I must divide both sides by 1,97. So if I go 2,94, divide by 1.97, I get 1,49, which is essentially 1,5. So then the ratio does this. 1 to 1.5. A lot of you now are going, well, then we round it up to 2. Do we? Really? Think about what you're saying to me. Then you're saying to me, if we round this up to 2, then aluminium oxide looks like this. Let's go back, because this is all a check for you. I want you to see where we're going. If we go back to what we know about valencies, okay, so I'm hoping you can see this. Aluminium has a valency of 3+. It's not multivalent. Okay, it has a valency of 3+. It's in group 3. Oxygen has a valency of 2- because it's in group 6. And however you've been taught to do this, but you would put these down. So that means I need 2 aluminiums, 3 oxygens. This is what I'm actually trying to get to. So to go 1 to 2, that's not right, because we can see it's not right. But look carefully here. If I times this by 2, okay, this becomes 2, okay, or not. This becomes 2, that changes to 3. Same thing. Look at my numbers here. This is very close to 2. Very, very close to 2. This is extremely close to 3. We could have actually rounded up right there because they're so close. Rounded that to 2, rounded that to 3. Okay? That's what we could have done. And then we realize that the empirical formula is Al2O3. Grade 10s. What I did here, for a lot of the empirical formulas you get, that's your check. It's a nice, easy way to check what we're doing. Use it, grade 10s. Don't be afraid to go back to this. Remember, you always have time to check. You must be looking at your answers and going, does that make sense? Does the answer I get from what I know make sense? Can it work? Okay? How do I know I'm right besides this? If we now go back and we say, okay, now in the testing exam you wouldn't have time to do this, but let's do it anyway. If I take Al2O3 and I say, okay, let's just check. Okay? Important that we do this. Let's find the percentage composition of aluminium oxide. Okay? So the first thing I need is the molar mass of aluminium oxide. Okay? Aluminium, there's 2 of them. Its mass is 27. Oxygen, there's 3. Its mass is 16. So I am going to need my calculator. So we're going to go 2 times 27 plus 3 times 16. And we get 102. Okay? So that's 102 grams per mole. I haven't lost any of you, I hope. Next thing we need to do is let's find, and this is also showing you how to lay this out. If we go and say, well, the percentage of aluminium is going to be the amount of aluminium, which is 2 times 27 over 102, because I want to know what is its percentage of 102, times by 100. Okay, and let's see. So, no, there we go. 27 times 2 divided by 102. 102, not 100. Go back. There we go. Times by 100 gives me 52.94%. Oh, surprise, surprise. Okay. Isn't that what we started off with? I told you we had 52, but let's just check. Maybe something goes wrong with the oxygen. I don't know. Okay, so percentage oxygen, there are 3 oxygens in it, so it's 3 times 16 over 102 times by 100. Okay, let's work it out. So 3 times 16, all right, divided by 102 times by 100, because we want a percent, and we definitely don't want it as a fraction. Oh, look at that, 47,06. Okay, oops, 47,06%. Exactly what we started off with, grade 10s. If you used, I want you to see this, if you left it as AlO2, which is what I know some of you would have got. First of all, the molar mass of this is 27 plus 2 times 16, so that's 59. Okay, 59. Let's just double check though. No, yes, 27 plus 2 times 16. Ooh, 16. 59. If we now look at, let's just take the aluminium, percentage aluminium. Watch what's going to happen. 27 over 59 times 100. 27 over 59 times by 100. Ooh, times by 100. Let's do that again. $45.76. That is nowhere near the percentage it should be. I know that this equation is wrong. I know it's wrong because when I look at the percentage composition, and it's a good way to check if you've got time, go back, do the percentage composition with the formula you got, and see your answer should match the one in the question. If it doesn't, then you've made a mistake. Be very, very, very careful, grade 10s. Well, I know I'm harping on this, but it's important that you check your answers. It's important that you look at your answer and go, does that make sense? Does it fit into what I know? Now, what you need to realize is we might no longer, you're not necessarily going to be told, okay, we are testing on whether you can write formulae now. So you're going to go back into your book and learn that. It's assumed that you know, grade 10s. All right? You're almost through grade 10. You're going into, trust me, next year it is assumed that you know. It is completely and utterly assumed. You've got to be able to write formulae. You've got to understand that section of work. It's so important. We did that in the first term. So this is 6 months later. You've got to get it in your heads. Okay. I think I've jumped and hammered them enough.
I think so.
Yeah,
I think I'm going to give them a break.
I think so.
Okay, guys, I see that there's quite a few questions on the page. What I am going to do is I'm going to get Tracy to have a look through them during the break, and we'll get back to them as soon as we get back. Now jump up, stretch your arms, stretch your muscles, and we'll see you guys now after the break. Okay, so now I've got a great question from Opar.
Okay.
And Opar has asked, do we always multiply by 2 on checking the empirical formula?
No. Easy answer, but I'll go. The reason why we did it in this one, Opar, is because when we got to this part where we got 1 to 1.5, we times by 2 to get rid of the half. If we had done the division, and we ended up with 1 and 2, like we would with water, okay? When you do H to O, if you do this method, you end up with a ratio of 2 to 1. You don't need to multiply by 2. Then you leave it as it is, okay? Because we're only multiplying by 2 to get rid of the half. That's the only reason why we have to multiply by 2.
Okay.
Okay.
Awesome.
Cool.
Let's carry on. Let us
move
carry on.
Okay, so now we get to the part which I know you guys hate. And then when I finish this, we'll go through the challenge question.
Yes.
Because we actually have found our winner.
Yes, we have indeed.
We
Yes.
did. I'm so
Yay.
excited. Anyway, so 20. Ooh, my HCl came out as a 1. I'm sorry, that's an L. Just pretend. 20 centimeters cubed. So we go, okay, I've got 20 centimeters cubed of a solution of HCl is required to react fully, which means it all gets used up with 0.265 grams of sodium carbonate according to this reaction. So we're okay. Sodium carbonate plus HCl gives me sodium chloride, water, carbon dioxide. Brilliant. First thing we do is it balanced. Okay, well, let's just check. 2 sodiums on the left, 2 on the right. 1 carbon, 3 oxygens, 1, 2, 3 oxygens, 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines. Brilliant, balanced. We're very happy. Next thing, calculate the molar mass of sodium carbonate. I was doing that just now when we looked at the aluminium oxide. Okay, so I just need to get my notes because I don't know the molar mass of all of these off by heart, though I do know some of them. That's just from my age, which shows. Anyway, first thing we have to do, we've got to find the molar mass of sodium carbonate. Let's just answer the first question. So how we set it out is important. The molar mass of sodium carbonate, we have 2 sodiums, so that's 2 times 23. We have 1 carbon, carbon is 12, and we have 3 oxygens, so it's 3 times 16. Please be careful with carbon and nitrogen. For some reason, I'm seeing this often at the moment, that you get confused between the nitrogen and the carbon molar mass. Carbon is 12, nitrogen is 14. Okay, so just be careful. We would put this all on a calculator. We're not going to do that right now. And we get 106 grams per mole. Okay, 106 grams per mole. Bonus, nice and easy. Here we go. All right, then. How many moles, that nice little furry animal thingy again, how many moles of sodium carbonate are there in 0.25 grams of sodium carbonate? This is a nice question, grade 10s, because we've led you. I've already asked you to calculate the molar mass. Now I just need you to use it, because remember, okay, went too far. Let's go here. And there we go. There we go. Number of moles is mass of the sample divided by molar mass. So we get 0.265 divided by 106. Now, 0.265, maybe I should put all the numbers in, divided by 106 gives me 2.5 times 10 to the minus 3. Okay, if we put this in non-scientific notation, so let's get it into normal, it's 0.0025. It doesn't matter which way you write it. It really doesn't matter. But guys, please, I'm begging you, do not round this off. Do not make this 0.003. Okay? It's exactly 0.0025. So that's what you need to write down. Exactly 0.0025 moles. I don't think I've lost any of you just yet. This was nice. Now, if we go to the next question. So now we've learned, okay, remember from the question we had 20 centimeters cubed of this, and this was 0.265 grams, which worked out to be 0.0025 moles, okay? Now it says, how many moles of HCl react with 0.265 moles of sodium carbonate? This is a mole ratio question. Now, you might have been taught this lots of different ways, but what I'm looking at here, grade 10s, is for every mole of sodium carbonate, according to my equation, I need 2 moles of hydrochloric acid. So for every 1 mole of sodium carbonate, I need twice as much HCl. Now, I know how many moles of sodium carbonate I have. We worked it out. That's why we made you work it out in the last question. So here, if I want to work out the number of moles of HCl, I'm going to take the 0.025 and times it by the ratio of 2/1. That's the ratio of sodium carbonate to hydrochloric acid. Okay? That's the ratio. Then we know that we end up getting 0.05. 0.5, sorry. Okay? So, in other words, we're taking that answer, times in by 2, 0.005. Okay. Mole ratio, 1 to 2, twice as much HCl as sodium carbonate. We need, it says we use it all up, reacts fully. nothing left over. Okay? Now, calculate the concentration of the HCl solution. Solution means solution, concentration. But what do I know about the HCl? I know the number of moles, and we were told, if this right, we have 20 centimeters cubed. Concentration, I do not have to tell you what it's measured in because you should know its units. Concentration is measured in moles per decimeter cubed. So first of all, I've got number of moles. Brilliant, very excited. Got volume. Equation we're going to end up using, if I don't, is concentration, number of moles over volume. The volume is 20 centimeters cubed. Wrong units. Has to be decimeters cubed, which means we need to convert it. Now, how do you remember this conversion? Because this is probably the one you're going to get the most. 1 centimeter cubed, this is just a little bit of an aside. Let's do it here. Okay. 1 centimeter cubed is the same as 1 milliliter. Okay. 1 decimeter cubed is equal to 1 liter. How many milliliters in a liter? You should all know this. 1,000. So if I wanted to convert milliliters to liters, I would divide by 1,000. So if I want to convert centimeters cubed to decimeters cubed, I divide by 1,000. Okay? So I'm going to divide by 1,000. 0.02 decimeters cubed. This conversion is so important, grade 10. You've got to get this. What I've written in blue, that's how I remember it. That's how I always remember it's 1,000, because it's one of those funny little ones. But some of you are going, hang on, wait, Tracy. Centimeters to decimeters, it's a factor of 10. Yes, it is. But this is cubed. So it's a factor of 10 cubed, and 10 cubed is 1,000. Okay, don't make a stupid mistake on something like that. Now, we know the number of moles, we worked it out earlier, 0.005, volume 0.02. So watch here, I've got it in there already, and it's exactly 0.25. Nice answer. We like answers like that. Don't forget our units. Okay, moles per decimeter cubed. Nice and simple. You could not even vaguely have used this equation. You didn't know the mass of the hydrochloric acid. You knew the mass of the calcium carbonate, and if I'd known what volume that calcium carbonate solution made, I could have worked out the calcium carbonate concentration, but not the hydrochloric acid unit because we didn't know the mass. The 0.265 grams was for the calcium carbonate. Okay, be careful. So, Indy.
Yes.
Do you think we can say who won?
Of course we can.
Let's say who won, and then I can answer the question.
Okay, is that how we want to do it?
What do you think?
Okay, let me just find the winner because there's quite a few.
Okay, the first one. Yeah.
Okay, are we going to say what the answer is first? Do you want to say what the answer
Should I
is?
answer? Yeah, okay.
Okay, answer it first.
And then we'll announce the one. I'm very excited.
Yes. Or just say the answer is number or letter.
Okay, well, guys, the answer is B. Okay? So, first thing, so if you answered, and
B.
some of you are crying now, screaming to TV.
I answered C.
You did, but C is right, Tracy. You're wrong. No, I'm not. Just.
Okay, so it's definitely B, hey? Because I was a bit skeptical. I
know, because like Indy was.
I was going
C.
C.
But you see, remember, I told you I chose this deliberately. Because, guys, there was a trick to this. Now, watch out. Question says 1 gram, and this is what our winner got. I was very excited, of hydrogen gas. Hydrogen gas is H2, not H. That's the trick. Hydrogen gas, when it's in its elemental form, becomes H2, which means the molar mass, which is what we're looking for, the molar mass of the hydrogen gas is actually 2 grams per mole, because there's 2 times 1. Which means, when we're looking at number of moles, if I have 2 grams, sorry, if I have 1 gram, and it's 2 grams per molar mass, that means the number of moles is 0.5. Okay, so we realize the number of moles is 0.5. The question has to do with volume at STP, and I'm hoping you guys all remembered, and I think by giving me C, I know you did, that molar volume is 22.4 decimeters cubed. And remember, molar volume is the volume of any gas when you have 1 mole of that gas at STP, standard temperature and pressure, where standard temperature is 0 degrees Celsius, or 273 Kelvin, and standard pressure is atmospheric pressure, 101.3 kilopascals. So we've got that, but I don't have an entire mole. So number of moles when it comes to volume is the volume we have divided by molar volume. So we have 0.5, 22.4, where V then becomes a half times 22.4, which is 11.2. 11.2 decimeters cubed. So grade 10s, which is B. I did it deliberately. I know it's been mean.
Meanie.
It is. But I'm actually testing a lot of things in this question. It seems like, and this is why I think you guys struggle with multiple choice, because you go, oh, it's so odd. But it's not. I have tested 3 concepts in one question. I've tested, do you know hydrogen gas is H2? Number 1. Can you work out that 1 gram of hydrogen gas is half a mole? Number 2. And the third thing is, do you know what molar volume is? 22.4, and if you have half a mole, then you have half of that. So 3 concepts, 1 question, it's only worth 2 marks. Be careful. We were mean, hey?
No, it was a bit mean, but the mindsetter, let's have a look. It was Rapolai Lesejo. You are the winner of this awesome Casio calculator. Please, can you email us your name and your postal ID to win@bubblegum.co.za. I've put that on the Facebook page too, just in case you didn't have time to get that done. And I think we're kind of getting to the end of the show,
there aren't any questions. Nobody is shouting at us for the last 30 seconds or so.
Okay. I think we've got a whole bunch of shouting people, but let's
not for good reasons, maybe.
Gosh. Okay, so now maybe this is a quick one. This one's from Pleasure, and Pleasure asks, if you want to find the correct ratio, you divide by the smallest number or what? Help, please.
Always by the smallest number, because you want to get one of your numbers to 1. Okay, sweetie. So you get your ratio, you work out the number of moles, work out the ratio together, and always divide by your smallest number. Absolutely. And then go from there. Sometimes, like with the element, you may have to multiply by 2 to get rid of halves. So you won't always be left with ones, but it's always to get to the smallest. Yeah.
Okay, awesome.
Okay. And I think that's it. Next week we're going to do physics, guys. So we're going to look at graphs and equations and all those things you really love. Yay!
Yay! Okay, guys, thank you so much, grade 10s, for an awesome show. We'll be seeing you the same time, same place next week. Don't forget that grade 11s are next, and Liberty, you guys rock. And thank you so much, Mindsetters, for posting so many amazing messages on our Facebook page saying, Liberty, you guys rock. We will screen grab them and send them to Liberty just so they know how much we really, really appreciate them. Thank you so much, grade 10s. See you. Bye.